Lesson 8.3 is hyperbolas. You will find a lot of similarities to ellipses, and you'll find differences. Okay, so you'll want to have the notes in front of you when you go to do homework and whatnot, because you'll want to have, your chart of information here. So hyperbola, I kind of talked a little bit yesterday. Hyperbola are the two outward curves. Back in lesson 1.3, it was the reciprocal function, right? Except that those were angled and they were in quadrants 1 and 3, okay? Or they could be in 2 and 4. The hyperbolas we're talking about today, if you look, they're either going to be on the x-axis facing out, or they're going to be on the y-axis facing out. So officially, a hyperbola is a set of all points in a plane whose distances from two fixed points have a constant difference. If you took the time to go back and compare this to the ellipse definition, ellipses were a constant sum. Okay? It was from the two foci, all the points have a constant sum. Well, this is going to be from the two foci, all the points have a constant difference. So they would have the same amount subtracted. The fixed points, again, are called the foci, okay, or two focuses. Now, notice, where are my foci? If you look at that picture, my foci are, I don't even know how to describe it. It's kind of inside the hyperbola curve, but they are out past the vertices. In an ellipse, your vertices are the farthest point out. Your foci are inside of the vertices and inside the ellipse. Here, vertices and foci are flipped, but it also, I kind of think of it like a parabola, where is the focus of a parabola? It's inside the curve, right? It's inside the bold curve. Well, here your focus is inside the bold curve, okay? The line through the foci is still the focal axis, so that's the foci to foci. The point halfway through the focal axis is the center. So similar to the ellipse, your center is in the middle. The points where the hyperbola intersects its focal axes are the vertices. So where your ellipse intersected the axes were vertices. Well, these right here are your vertices. So you have a great picture to help you through here. Now, one difference. We don't have a major and a minor axis. We have a transverse axis and a conjugate axis. So the chord line on the focal axis connecting the vertices is called the transverse axis. So in this case, on this one up here, that main horizontal axis, the one that goes through the vertices and through the foci, is your transverse axis. I would kind of relate the transverse axis to the major axis. Your transverse axis has the vertices and foci on it. Conjugate axis is the perpendicular one. So it would be the one, and it's not drawn in this picture I'm realizing, but the conjugate axis would be the perpendicular one that goes through the transverse axis there. Okay? So transverse axis would be this one. Converse axis would be that one, if that helps any. Now, very much like ellipses, we're going to have two charts. We're going to start with the basics. We're going to start with hyperbola centered at 0, 0. And then when we get to the backside, we'll go to hyperbola centered at HK. So, what do you notice about our standard equations today? There's a minus. Okay? They're very much like ellipses. I told you there's a lot of similarities, but there's some differences. Except that with an ellipse, there's a plus sign in the middle. With a hyperbola, there is a minus sign in the middle. Okay? We still have left column versus right column. Left column is when your main axis, in this case the transverse axis, is the horizontal. So when your vertices and foci are on a horizontal axis is your left column. Right column, your vertices and foci are on a vertical axis. Okay, so focal axis, foci and vertices, you'll notice similar, right? Just like if you look back at the ellipse, it'd be the same type thing, plus or minus C, plus or minus A. Transverse axis is 2A. So as I said, transverse axis takes the place of major axis. Conjugate axis is 2B. What about this Pythagorean relationship?
Or no?
It's not the same.
It's plus.
Now there's a plus sign in my Pythagorean relationship. It's actually technically the Pythagorean theorem, right? But there's a plus sign in the Pythagorean relationship. So that's one thing you have to watch out for. If you can remember, so the ellipses had a plus in their equation, but the Pythagorean relationship had a minus in it. Well, now it's flip-flopped the other way. The hyperbola has a minus in the standard form equation, but the Pythagorean relationship has a plus in there. And then we have one other thing we have to add in today, and that is asymptotes. Okay, now, I'll be honest. I don't really use this formula for asymptotes very much. On the rare occasions they ask us to find the asymptotes, okay, I'll use this formula. When it comes to drawing asymptotes, I have a totally different way to do it, so we don't have to worry about actually graphing a line. And I'll explain that when it comes time to graph. I'll show you how I graph those. But we do have formulas for asymptotes when you're asked to find them. Okay? Let's see. Anything else here? I don't think I have anything else here. Again, just notice vertices, kind of like a parabola. Vertice is where the bottom of the curve, right? Foci is inside the curve. Okay, shall we look at example 1?
I guess.
Okay.
May as well.
Find the vertices and foci of the hyperbola 4x squared minus 9y squared equals 36. Okay. Well, this is going to be similar to our first ellipse example from a couple of days ago. In order to find the vertices and foci, we need things like ABCs, right? In order to find ABCs, we need this equation to be in standard form, which it's not. How do I get this equation in standard form?
36.
Yeah. We want this equation to equal 1. So to make it equal 1, divide by 36. If we divide one side by 36, we're dividing the other side by 36. So, 4x squared over 36. Well, what do you know about 4 over 36? Yeah, it's going to reduce to 1/9, so x squared over 9.
This looks very similar to that.
Minus 9y squared over 36. Well, what do you know about 9/36?
Oh,
It's 1/4, so y squared over 4 equals 1. Okay. I can also rewrite this as x squared over 3 squared minus y squared over 2 squared equals 1. I'm not sure how necessary that is now because I think you have a pretty good understanding of a squared versus a and all of that. So,
God.
okay. Now, left column, right column.
Left.
Why?
Because A is bigger and it's under X.
Okay. I'm going to delete the comment because A is bigger. Huh?
The number under X is bigger.
Okay. So here's, I said ellipsis hyperbola is very similar, but there are some differences.
Oh, this is a difference.
This is a difference.
See, that's
Okay,
why I didn't
and here's the deal.
answer.
Okay, you might want to make a note. A does not have to be bigger in a hyperbola.
What?
There's a different way that I know this is a left column problem.
You tricked
And it's not about A versus B, which is bigger, which is smaller. Because in a hyperbola, A does not have to be larger.
me.
What?
Yeah.
What do you mean about
subtraction.
order?
That can't be.
Oh my gosh, yeah.
Okay, so it's subtraction. X is first, it's subtraction. So which is the one where X is first? The left column. I can't flip-flop this one like I could earlier. Okay, so this is one of our major differences between hyperbolas and ellipses. Okay, that you'll have to work to get straight in your head. This one, I know this is left column because X comes first. I can't flip-flop this, or I could flip-flop it, but if I flip-flop it and put it X second, then it's going to have to be negative y squared plus X squared.
That's just-
And that's not right. We want the minus sign in the middle.
Tricked me.
So,
See, I didn't answer this.
well, But here's the deal, guys. I'm looking for someone to say because A is bigger, so we can blow that out of the water from the beginning.
I fell for it.
Okay? So I needed
Well-
someone to go there for me.
I can tell something deep.
Okay? So this is A, left column, and it's left column because,
X comes first.
yeah, I'm going to say because x squared is first. Not because A is bigger, because x squared is first. Or I guess, I shouldn't say because x squared is first. I should say because x squared is positive. That's really what it should say if you think about it. I'm going to just because if you want to get weird and you want to write the negative y squared first, well then y squared's first, then yeah, okay. So what is A then?
3.
A is still 3. What is B?
2.
B is 2. Okay. So let's see. We were asked to find what? Vertices and foci. So let's start by finding vertices. How do I find vertices?
Plus minus A.
comma 0.
Okay.
Times B.
Because this is left column, because x is the positive variable, this is horizontal, x-axis is the transverse axis, so plus or minus A, comma 0. So we are simply going to say plus or minus 3, comma 0. That was tough, wasn't it?
There.
Okay.
I have rank here.
What about foci? What's my formula for foci?
A squared plus B squared plus C squared.
What's my formula for foci?
Well, plus or minus C, comma 0.
Okay.
You have to use the A squared plus B squared plus C squared.
Not arguing that, just looking for the answer to my question.
Maybe you should.
Okay, so the formula for foci is plus or minus C, comma 0. The catch, as you guys all are well aware, is that I don't know C. And in order to find C, Pythagorean relationship, which is C squared equals
A squared plus B squared.
A squared plus B squared today.
I joined.
So
Thank God.
we are going to have, I was going to say 3 squared, but 2 plus 2 squared, but yes. 9 plus 4, which is 13, and so C is square root of 13. And so my foci, plus or minus square root of 13, comma 0.
Say 0.
Okay. Very similar. Watch out for the changes today, right? Okay, let's look at example 2 when you're ready. This time we're being asked to find the equation of the hyperbola with given foci and a given conjugate axis length of 4, and then sketch the hyperbola and its asymptotes.
It's gotta be.
So,
Yep, that's right. I agree with Mario.
we need an equation
I said that.
and we need a sketch. Okay, thoughts that you can share. We don't know enough information to sketch it right now, would be my comment.
So the conjugate access, I mean,
Well, let's find.
that's equal to 2b. Has
Okay.
length of 4. We can do some pretty quick math right there.
Conjugate axis, length 4. Check your chart. We don't have to know which column we're in here. 2b it is always conjugate axis, so if 2b is 4, then we know that b is 2.
We can find A with our foci.
Are you sure about that? No, you can find C.
Okay.
Oh, we can find C with our foci.
Okay, so these foci are in the form 0 plus or minus c, aren't they?
Yes.
And so what do we know c is?
3.
C is 3. What else do my foci tell me? This is a right column problem, okay? Because of this form here, this is going to be a right column problem. So when I go to write my equation, I'm going to be doing y squared over a squared minus x squared over b squared equals 1. That's the equation I'll be filling in. What else do I need to find? And how do we find a?
A squared minus B squared equals C squared.
Okay, good old Pythagorean relationship. So c squared equals a squared plus b squared. What do I have? 9 equals a squared plus 4.
So A should be the square root of 5.
Okay, a squared is 5. A is the square root of 5. What is the square root of 5 approximately? We're going to need to know this later.
2.3 something? I'll get my calculator.
2.22.
I think you're
I'm
all
thinking
wrong.
it's 2.25. I'm thinking it's 2.2 something, but
Let's check.
I'm going off of memory.
2.23.
2.23.
Okay.
I said 5.
Wrong.
No, I said 2.23.
Okay. So, and it's not that you have to know that, but here's the deal. We're going to be graphing here shortly. And when we're graphing, we're going to have to be able to graph a distance of A. I don't know what A is. I don't know how to graph a distance of square root of 5 unless I get that written out. Okay, so equation. Y squared over what?
Squared.
Square root of 5 squared, which is 5. So y squared over 5 minus x squared over
4.
2 squared, which is 4, equals 1. I went ahead and went straight to 5 and 4. If you wrote square root of 5 squared and 2 squared, that's fine. Okay, I would suggest you clean it up for a final answer, but okay, I think we are ready to graph.
Yes.
So I again tried to leave space in the center. This graph is centered at 0, 0. Okay. And I know this graph is centered at 0, 0, 1 because I haven't introduced you to HK yet. And 2, because the form of my foci. The form of my foci being at 0, negative 3 and 0, positive 3, that tells me it's centered at 0, 0.
So what are we going to do HK?
We turn the page.
Oh, sweet.
Okay, so I probably need to go, what, about 3 out on each column? Okay, so we can already graph the foci of 0, negative 3 and 0, 3, correct? So 0, negative 3 and 0, 3. Remember, this is a right column, so they should be going up and down, yes. So those are my foci. I'm going to put F's beside them. Also remember that these are your C values, right? So whether you want to think F or C, well, I don't know. But we also went, what, 3 out? I'm going to put C's there. It's your C value, it's your foci, okay? Now, where do we find our vertices at?
So square root plus
Okay, they're at A, and A is the square root of 5. This is why I said we need to know
2.23.
that fun 2.23. Okay, so now, and which axis are we doing this on? The same axis where your foci are. So we're going to go, yep, y-axis. We're going to go up 2.23, and that is a vertice, and it's up A, and we're going to go down 2.23, and that's a vertice, and that's down A. Okay, so they are A from the center. Now, what do you think your B value tells you? What did my B value tell me on ellipse? If you go back to ellipse, A values told us how far to go out on the major axis. Also gave me my vertices. B values tell me how far to go out on my minor axis. So in this case, the x-axis, the conjugate axis. So, and it's not that you're technically putting points here, but B is 2. And I tend to put a point here for lack of what else do I do. But this is just going to help me draw asymptotes. So put some kind of point or mark 2 each way, and we're doing at 2 because those are my B values. Okay? Now, you will never see me just automatically draw my hyperbolas. Okay? Because here's the deal. How wide are my parabolas? Hyperbolas. Or how skinny are they? Okay? And that is what we use the asymptotes for. Now, I mean, officially, where are my hyperbolas going to go? One's going to open up. The other's going to open down. And where do they go through? They go through the vertices. Now, here's the deal. What I do to draw my asymptotes, unless you want to, what's the formula? Plus or minus a over bx. So we could try and graph the equation that is plus or minus the square root of 5 over 2x. So do you want to do a slope of square root of 5 over 2? I prefer not. So instead what I'm going to do is I'm going to make a box. And I'm going to make a box using my A and my B values. So I'm going to make just a dotted line box that goes through A's, which A's are my vertices, and it goes through B's. This is the only reason I even graphed B. So I just made a box, rectangle, and it horizontals through the A's, verticals through the B's. And here's the deal. My asymptotes go diagonally through that box. And that's what we're going to sketch in here. So one asymptote, and my asymptotes should also always go through the center. So I'm going to have an asymptote that goes that way. It went through the center and through the 2 corners of the box. And I'll tell you what, I do better if I draw my asymptote one way from the center and then the other way from the center. I struggle otherwise to hit all 3 points with a straightish line. My other asymptote goes through the center and through the other corners. It doesn't have to be perfect, but I want to be able to tell, did you try and put your asymptotes through here? If you have random asymptotes drawn on your test, and it doesn't look like you tried to get them through those points and use the box, then I'm not going to give you full credit. Okay? And now we are ready to draw our hyperbola. Hyperbolas are the A values, the vertices, yes? And here's the deal, is that it goes through the A value, and it runs alongside, the hyperbolas, or the asymptotes. So the idea is that the asymptotes determine the width of the hyperbolas. Okay? So notice hyperbolas, they go through the vertices, and where are the foci? The foci are inside those curves. Or outside of the vertices. I don't even know how I want to describe that, but I think of them like parabolas, how they're inside the curve. Okay. You have graphed your first hyperbola.
I think it'd be worse.
It wasn't as bad as I expected.
It's not horrible. And I will say, using the box for the asymptotes is 100% better than trying to do a slope of square root of 5 over 2. That just sounds horrible to me. But that's essentially what that doing the box did. We would have had a slope of A over B, So we would have had to go up square root of 5 over 2, which is essentially what we did. And up square root of 5 left 2 from the center. And here at least we are centered at 0, 0. You won't always be centered at 0, 0. Okay. Back page. Connor was wanting to know when we get to HK. We're here.
Here it is.
Okay. Now, you guys know how the ellipses work, yes? Same thing with hyperbolas centered at HK. Basically, you know, instead of x squared and y squared, you have x minus h squared, y minus k squared. Same idea. Your foci and vertices, instead of just having the plus or minus a and c, now have the h and k in there. Your transverse conjugate axis Pythagorean relationship all stay the same. If you have to write an asymptote equation, it looks a little fancier now, doesn't it? You still have the plus or minus b over a or a over b for the slope, but then you'd have to fill in the h and k values as well. Okay? I'm not even going to try and point out the pictures because they just look kind of like a mess, but it's the same setup as the front side. And we also, again, are going to talk about eccentricity. Guess what the formula for eccentricity is? C over A again. Okay, now, the difference here is that eccentricity of a hyperbola is always bigger than 1. With an ellipse, if you go back and read, it says it was always between 0 and 1. This is always bigger than 1, and it's used to describe how wide the hyperbola is. Okay? Ready? Give it a try.
Better, better. Let's get better.
Example 3. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1, and whose conjugate axis has length 8.
See, that's what
I feel like I should just agree with Margo.
Hannah said it too.
Yeah. But the -1 are the same. So
Okay, so,
left column does make
Because the K
sense.
never changes.
okay, words are being thrown out about the left column. People are also questioning left column. Okay, why?
The K never changes.
Oh, no.
Okay, so as we look at these endpoints, that's the K value, isn't it? That's never going to change. Now, transverse axis endpoints. What is another word for transverse axis endpoints?
Major.
The what?
Major axis.
Okay, so transverse axis, major axis, same idea. What's a specific name for those endpoints, though?
Vertices.
The vertices, yes?
Yes.
Okay, so the end of the major axis was vertices. End of the transverse axis are vertices. So the idea here, transverse axis endpoints, those are the vertices. And so if we go back to the idea that the K is the same, think about the fact that vertices, when you look at the left column, are H plus or minus A, comma K, right? And so that right there is how we are going to be able to say that this is left column. If you want, we can already note that this is K. So let's see. If we talk about, let's see, are we going to have to write the equation? Yes, we do. That is the whole goal here, isn't it, I guess?
Precisely.
Okay. So that means here in a little bit, what do we say, left column? So that's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. Don't forget that minus, guys. Okay. I started second guessing. Did I use minus on our previous example? Hopefully you guys would have called me out on it if I didn't, but I don't know. I think
we did.
Really early.
I say. I did. I checked. Okay. So, in order to write this equation, I have to know A, B, H, and K. Currently, I know K. What else do we know?
B is 4 because it's 2 B.
Okay. So, conjugate axis. Conjugate axis has length 8. So, 2b equals 8, and b equals 4. Okay. We have half of them.
A equals 5. 2A.
I'm sorry, what?
A is 5 is what I'm being told.
Because 8 to 2 is 10, so then you have 2A equals 10.
Okay. So, this is the... Some of you are visualizing without graphing, which is fine. I'm going to graph it here in a moment. But what you can notice is that transverse axis endpoints. One vertex is at -2. The other vertex is at 8. How far apart are -2 and 8?
2.
They are 10 apart, which that means my transverse axis has a distance of 10. And if my transverse axis has a distance of 10, 2A is 10, and A is 5.
Now we're saying 5H, which is also very easy. Right? Yeah. Could you just do like a little H plus C equals -2,
Or you could just do
or H minus C equals 2.
Kylie.
Or look at the second column where it says x equals H. And it gives you a solid.
I think my way was the best way, personally.
Solid.
I think you meant plus or minus because those are vertices, not the that.
I said plus or minus, didn't I?
Plus or minus A.
What?
So what are we suggesting H is?
Number 3.
Huh?
You just go.
Whoa.
You just go.
Just 3.
She can explain.
I agree with 3.
Yeah, she
Yeah.
can explain it.
Because
Oh, because 5 minus 3.
Because here's the deal.
Negative.
5 is my A value, yes?
5 minus
So my center, from my center, we count 5 out to one vertice and 5 out to the other vertice, right?
Which would be approximately.
And so if my vertices are at -2 and at 8, what is 5 in from -2 or 8?
3.
3. And so we can also argue that our center is -3, -1. And that is your H and K. Right?
Yeah.
Okay? Now, I will say in my notes, I have a picture drawn.
Cheater.
We essentially just did this without a picture, didn't we?
Yay!
Okay? Which is perfectly fine. If you are struggling, I would have said, sketch a picture. And by sketching a picture, what I could have done, -2, -1, 8, -1. And so once I have that visual, some of you might need that visual, that helps reinforce the fact that how far apart are they?
Pretty far apart.
So pretty far apart, they're 10 apart, right? And so then when I start, these are my vertices. When I start counting in 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, I land there in the middle.
So it's 3,
Where'd you put that?
not negative.
Yeah, you put negative.
Oh, well, then say something.
I just realized that Mario started talking about it.
Then why did you say
So
something,
don't ask
Mario?
me. Why did you say something?
Mario
I thought I was gonna
pencil,
remember.
pencil led Gus.
He had a weird look on his face, I know that, but he wasn't saying anything, and I didn't catch my own mistake, obviously. So, okay, so obviously the -3 was crazy talk. Can we agree with positive 3, negative 1?
Yes. There we go.
Now Mario's happy.
Okay.
I'm
So,
yeah.
for the what we talked about, I just said the wrong number, wrote the wrong number, I don't know.
Yeah.
Okay, so the idea here is that if we are graphing this, these are my A values. B would be what?
Or
So your B values would go up here and down here. And your A values are your vertices. So do you see the box you would draw? I'm using this as a little bit of graphing review. Okay. The box would go through the B values that you just counted up and down to. And the box would go through the transverse axis endpoints. And that is where you would get your asymptotes. Okay? Because then your asymptotes could go through the center and the corners of the boxes. The box. My drawing just looks like a big hot mess right there. Is what it's looking like. I mean, I'm gonna call it as it is here. And then, which way would my hyperbolas go?
Sideways.
It's a sideways one, right?
Welcome.
So, something along that line, right? Did you write your equation ever?
no.
I haven't written mine, so maybe you've written yours, maybe not.
Have you heard it? Yeah.
Okay. X minus 3 squared over A squared, so 25. What sign? Minus Y minus
+1.
negative 1, so Y plus 1 squared over
16.
4 squared, which is 16, equals 1.
I like to see.
Okay,
Mr. Hernandez.
let's go ahead and talk about example 4.
Can we,
If we don't get all the way through, then we don't get all the way through. We will live.
for eccentricity, you would just find C and then have C over A and you're done. If
Yes.
we had to find eccentricity.
Yes. Yeah, it's just C over A. Okay,
You have a coat.
example 4. They give us an equation, and they ask us to find center, vertices, and foci. Okay? So, it really comes down to identifying all your information so you can find center, vertices, and foci. Which column would you call this?
I'd say it's left hand.
Why is it left-hand column?
Because X
Because
comes
X
first.
comes first.
Because X comes first. It is the positive variable, yes?
You said it's because A was bigger than B.
So this is a left column. This is of the form X minus H squared over A squared minus Y minus K squared over B squared equals 1. Okay? Just matching up the form there. What is H?
-2.
Negative 2. What is K?
5.
5. What is A?
3.
3. What is B?
7.
7. Notice B is bigger than A this time, right? And we're okay with that because it's a hyperbola. Okay? I would not be okay if this is an ellipse. And I see the word foci, so what's C?
Yeah.
Okay?
9 plus 9.
So C squared equals A squared plus B squared. So C squared is 9 plus 49, which is 58. So C is the
Square root of 58.
square root of 58.
Let's see.
I don't think there's any perfect squares in there.
That's about my
I think it's just square root of 58.
What are some perfect squares?
So,
This is the first time I think I've ever seen the square root of 58.
okay.
It's ugly.
I've never seen 58 under radical.
Well, and all I can say here is 58 divides by 2. I don't know anything else that divides by off the top of my head. So, I think we're probably good.
4.
2 and 29.
So,
Yeah.
okay. Is it, yeah, and if it's 2 and 29, 29's prime, so it's not going to do anything else. Okay. Center. What you got for the center?
-2, 5.
-2, 5, because our center, of course, is H and K. Okay. Vertices. What you got for vertices? What's my formula for vertices?
H plus minus 5 and negative.
No, wait. Nope. I wrote that wrong.
Yeah.
Sorry.
Oh man.
H plus or minus A, comma K. Is that better?
Yes.
I had a moment. And so this is going to be -2 plus or minus 3, comma 5. Do I like that answer?
Sure, you right.
No.
Oh, you got
Not for a final
That's
answer.
easy math.
That's easy math.
Get that off.
-2 plus 3,
-5.
positive 1, 5. -2 minus 3, -5, 5. Don't be lazy, do the easy math, right? And
Yes.
foci, real quick, I didn't think we'd get through this, but foci is going to be H plus or minus C, comma K. So -2 plus or minus the square root of 58, comma 5. Do I like that one?
Yes.
Yes, because I can't add or subtract square root of 58. Okay, tomorrow we need to do something from the back page. It's going to be similar to last time, but we'll work on, we'll do one example from the back page and then plan on some work time.
So,
And I will, work time, question time, officially it'll be due on Thursday, but you'll have some work time, yeah. It will not officially be due tomorrow, okay?
Okay.
We really